All right, so for our speaker today, Ushnish Sengupta is an award-winning instructor at the Schulich School of Business at York University and is an open data enthusiast. Ushnish's PhD thesis at OISE at the University of Toronto is focused on understanding data governance in social economy organizations. I will stop sharing my screen and pass it over to Ushnish.
Okay, so I'm assuming everybody can see my screen. Thanks for the introduction. And I have a lot of slides, so I'm going to go through them quickly, but I'll make them available later so members of the Civic Tech community can access them if you're interested in any particular element. So I'm here to talk about algorithm registers. So I'll talk about why we need algorithm registers. Sometimes they're required by law, such as in France and New Zealand. Sometimes they're required by court decisions. Talk about algorithm registers in Canada and Ontario. And I have a short section on how we create algorithm registers. So why do we need algorithm registers? Because most citizens don't know that they're subject to algorithmic decision-making until something goes wrong. So there's a lack of transparency. Essentially, you don't know what you don't know. And algorithm registers provide transparency for government. There are registers being developed at all levels of government. So the most advanced development of algorithm registers are in France, the Netherlands, New Zealand, for different reasons. So this is an example of what an algorithm register looks like. So it's a curated website. It's a list of algorithms used by the government. In this case, is the city of Nantes in France. There's two algorithms highlighted here. One talking about subsidies for transportation, and the other one, I think, is subsidies for water. So if you are accessing these services and you're eligible for a subsidy, you need to know how that subsidy is calculated to determine your eligibility. So that's important as a citizen. So as I mentioned, in France, this is a law mandating transparency of public algorithms. So governments across all levels in France, cities, provinces, the federal government are publishing algorithm registers because this is a law. Different reason for publishing algorithm registers is because of court judgment. So in the Netherlands, they had a court case where an algorithm was being used to determine welfare payments and welfare eligibility. And it was determined that many immigrants, particularly racialized immigrants from low-income neighborhoods, were being excluded from the system. And so a number of organizations and individuals took the government to court, and the government lost in court. And of course, they had to stop using this particular algorithm, but that wasn't the worst consequence. This particular government actually fell because, it starts with something like an algorithm register and excluding a whole bunch of people. But when that snowballs into affecting thousands of people, it becomes a political scandal, and you get enough political scandals, the government falls, right? So that's another now. City of Amsterdam, for example, among other cities, they have an algorithm register. And you can see the examples here. This one is in English: automated parking control, reporting issues to the public, illegal highway rental. But again, a very basic website with a curated list of algorithms of interest to citizens. So let's flip to Canada. Does Canada have any algorithm registers? I'm going to say not yet, but they have kind of pseudo lists. So in Canada, for example, high-risk algorithms used by the federal government have to go through this assessment called algorithmic impact assessment. And if there's an algorithmic impact assessment, it gets published on the Government of Canada Open Data website. And therefore you can access the list of assessments. Notably, not the algorithm. You can't look up the algorithm and source code and so on. You can look up the assessment, but that tells you that this particular algorithm exists and this is the assessment, right? The list is pretty short. There's 2 on that screenshot and there's 3 here. So there's like a total of 5 or 6 algorithms on this particular list on the Government of Canada Open Data website. Of course, the Government of Canada uses these thousands of algorithms. So this list is only the list of algorithms that went through the algorithm impact assessment. One algorithm that's not on that list, that didn't go through an impact assessment that was published, is called Chinook. It's getting a lot of attention. There's a number of immigration lawyers that are trying to reverse engineer this algorithm. So they've asked, this is the algorithm developed by the government. It's not purchased from the private sector. They've asked the government to explain how it works, to provide details on it. Essentially, the government has refused. So the lawyers have done freedom of information requests, ATIPs in this case, and gotten hold of the manuals that are available for this algorithm and tried to figure out how this algorithm works in that way. Another way, because it's a number of lawyers who are facing kind of a bunch of anomalies, seeing a bunch of anomalies, and they say, look, let's pool our resources together and see the messages that get, and when somebody gets refused for a particular immigration visa, you get a message like by mail, sometimes by email, but that text is often generated by this algorithm, right? So they said, okay, let's pull together all the different text messages we're getting and how frequently you're getting them. And that way we can reverse engineer this particular algorithm. So why is there so much attention to this algorithm? Because there are indications, there are biases built into that algorithm. My own sort of conclusion, and some of the others are kind of coming to it, is that the algorithms will reflect the biases of institutions. So for example, this is the permit refusal rates in Canada. And you can see there that there's a trend. And essentially, it's Francophone African countries that have the highest permit refusal rates across the world, right? In terms of people applying for permits to come to Canada. So there's a bunch of biases in the algorithm. Nobody's exactly put an exact finger on it, but there are a bunch of people trying to reverse engineer it and trying to figure that out. So that's one of the benefits of having an algorithm register, to say, hey, these are the sort of potentially high-risk algorithms. Let's investigate them further. This is an example of a more substantial algorithm register. So it's called the Observatory of Algorithms with Social Impact. And when we say social impact, essentially talking about negative social impact. And the Chinook algorithm, which I mentioned in the last couple of slides, is on this list. So Canada's on this list. One of Canada's algorithms has negative social impact, and it's on the Observatory of Algorithms with Social Impact that the organization called Ethicus has put together. So you can see it's a basic table, a bunch of kind of columns with different fields. And I think that's a very useful format for an algorithm register. Other types of registers, this is an AI and algorithm automation incident repository. So it's not a list of algorithms, but it's more of a list of incidents. And I've convinced the main sort of developer of this particular list to add a column on algorithm or system, and that'll make these incidents searchable by algorithm, right? So if you have an algorithm with a problematic sort of impact in one jurisdiction, you probably have this similar problematic impact in another jurisdiction where that same algorithm is used. So the interesting thing about lists like these, you can see a trend. You can see how from one incident in 2011, you can head up to 260 events last year. And this year, I'm sure there'll be 300 incidents related to AI and other types of algorithms that'll get on this list. These are all published news stories. Now, we're getting into the last section in terms of creating algorithm registers. So how do you create algorithm registers? One potential method is corporate client lists, right? So an organization, and in this case, most people know about the story of Clearview AI. Their corporate client list got leaked. So there was a number of news reports on it. Reporters looked up where Clearview AI was being used. And of course, it was being used by dozens of law enforcement agencies in Canada. They were all queried. Number of them initially said, no, we don't use Clearview AI. And then they came back a few months later and said, yes, we do. We found somebody in some department using Clearview AI. So this is kind of another list. If again, an algorithm has a problematic impact in one jurisdiction, let's say the States, if that same algorithm is being used by law enforcement agencies in Canada, it probably has those same problematic impacts. And this is one way people identify the use of algorithms kind of across jurisdictions through client lists. Another potential method for determining algorithms in use, as I mentioned, that whole algorithmic impact assessment tool used by the federal government of Canada. So if you have some kind of filter that says, hey, these are the algorithms we're going to identify, and you can publish that list. So that's still like a register of sorts, an incomplete one, but at least you have a defined criteria, like a filter tool that identifies all the algorithms. In terms of another approach is doing a survey. So the government of Ontario, in this case, intends, or has, I should say, published an algorithm register of sorts. And the approach they used was a survey approach. So they surveyed all the departments within the government to ask, hey, what are the algorithms you use? And you can see kind of the blue, I know it's in small text, but there's a blue rectangle. It's a tag that is developed for this purpose, saying, hey, this particular item is an AI sort of application or an algorithm, and they're tagged in that way so that people can search for them, identify them, and so on. And so there's a list of 9 algorithms that the government of Ontario has identified in use by government departments. Again, the government of Ontario uses thousands of software applications. They've identified 9 because they asked, did an internal survey to identify algorithms. And by the way, this list of 9 algorithms has remained at 9 or 8 or 9 for like a year, right? So it's not that they've been cumulatively adding to this list and developing this list. And the government of Ontario, so it's not because there's a law requiring the government to publish this list, not because they lost a court case. It's a voluntary agreement that the government of Ontario made with the Open Government Partnership, saying in the blue there that one of our deliverables is we'll complete a people-focused refinement of Ontario's artificial intelligence and algorithms inventory through user research, right? So there's a commitment to do an algorithms inventory. And so if you are the type of person that says it's a binary, yes or no, did they do the inventory? Yes, check mark. There's the list of 9 algorithms. If you're the type of person say, okay, so what's the quality? How good was it? It's really incomplete, right? As I said, the list has been stuck at like 8 or 9 for a whole year. This is more of a bottom-up approach. This is more of a civic tech approach. So you can look at procurement documents, right? So I've been looking at procurement documents for the government of Ontario and identifying the algorithms in use. So there's the list of the 9 algorithms that they've already have on their website, but I was trying to identify any algorithms that have an AI component in it. So for example, the government of Ontario purchased or a GoBot, right? Essentially a chatbot, and was using it for a while. They're not using it anymore. So this is from a procurement document, and I'm using procurement here in a very broad sense because as I'm going through this kind of process, I'm finding that sometimes it'll be an algorithm that the government's purchased and used or is in use, like the GoBot, right? There's others which they're funded. So for example, there's a power line maintenance project that had an AI component to it that they funded, right? Then you come across some really interesting ones. So long range AI enabled unmanned aerial drone, right? So not that the government's currently using this particular system, but they funded a project on this. So that kind of raises a bunch of questions, right? Why is the government of Ontario funding a project on long range AI enabled unmanned aerial drones? In this particular case, the primary application was kind of traffic control. So you say, that's benign, but think about this technology in the hands of law enforcement, right? And there's a few ones. So I'm kind of going through this process of identifying the different algorithms used by Ontario government from procurement documents. This is a completed project done by Anna Brandersescu, and she looked at all the AI sort of investments the federal government has made, right? And say, identifying all the companies, the dollar amounts, the type of projects, and there were some really interesting companies that showed up on that list of federal government procurement for particularly AI. And Palantir, for example, was on that list, right? This is what a completed project. So my kind of list of Ontario algorithms is very short right now. When I finish it, it'll probably be a much longer list. This is the kind of work we've been doing in the group that was formerly known as the Tech Audit Group. So Hendrik essentially looked at the City of Toronto budget documents. So the City of Toronto budget documents look like this, at least the financial component looks like this. So what's interesting about it, A, it's a table, so it's easily scrapable. B, there are line items with dollar amounts, right? So now you have a bunch of information saying the city is paying for this particular system, and this is how much they paid for it. That's of interest, right? Because each of those line items now can be put in a spreadsheet, like I said, and it's scrape this PDFs, put it in a spreadsheet. So now we can take that spreadsheet and do a bunch of analysis on it. We can add a bunch of columns. We can identify if it's a technology project. So for the purposes of building like an algorithm register, whether it's a technology project is interesting, whether it's an AI application or not, it's interesting. And then you can prioritize like a high, medium, low risk type of thing, right? So you can say Clearview AI, yes, high risk. City of Toronto, Toronto Police Services in particular, uses another facial recognition tool called New Face. Nobody really knows too much about it. Nobody has complained a lot about it, but it's in use. It's a budget line item, right? This is how we identify it. And there's a couple of other ones which are kind of interest, right? So again, a bottom-up approach looking at budget documents. Finally, I'm going to put in a pitch for this workshop I'm doing on May 28th, Saturday. I'll put the link in the chat in a minute. If you want like a longer version of the tools and techniques of how to develop algorithm registers, we're hoping that people in cities all across the world start developing them. If the city itself is not doing it, I would encourage the citizens to do it. And some of the methods I've shown, basic spreadsheets, basic websites, things that everybody can do. So I see that we're at 7:40. I'm going to stop there and put this link into chat for those of you interested in doing an even deeper dive. But I'm happy to answer any questions.